Dear friend, up to now we have seen that how different light models were introduced by renowned scientists. We learned that initially the corpuscular theory was introduced, then wave theory, then electromagnetic theory of light, and ultimately that is established that light is one wave and it can move in a vacuum. Now it has been established that for some phenomena, light is considered to be like wave, and we have understood the words like interference, diffraction, and polarization, which are the phenomena which require the wave theory of light. So it is very clear that initially it was believed that light moves on a straight path, but later on it was established that light is straight path or light moves in a straight path is a special case, while in a actual the light is a waveform and it experiences different phenomena like interference, which is based on a superposition principle, then diffraction, which is based on Huygens and Fresnel principle, and third, that is polarization, which is based on the fact that light waves are transverse electromagnetic waves. So all these things that we have understood in terminology, now we will go and learn it in a detail. In first of that, we will try to understand Huygens principle. Now, to understand Huygens principle, we need to understand what is wavefront. Actually, wavefront is not introduced over here, but the detailed understanding we required that will be explained over here. So what are wavefronts? So first of all, we understood the term wavefront is. So it is very clear. Suppose we throw a stone in a surface of still water. Now what is our normal example? We can see, suppose a person is there throwing stone into, suppose, a still water of pond. Now if here there is a still water of pond, then what we will see that it will form this type of fringes in the water. Okay, so if the stone is thrown in a still water which was initially still, then it will experience this type of circular patterns of alternate crest and trough begin to spread out from the point of impact. So it is very clear that if this is the point of impact, the waveforms start moving on this path like this. So first thing that we want to understand is that what is the motion of these water waves. Clearly, all the particles lying on a crest are in the position of their maximum upward displacement and hence in the same phase. Similarly, all the particles lying on trough in the position of their maximum downward displacement and therefore they are also in same phase. The locus of all such points oscillating in the same phase, and that is called wavefront. That is the combination. So here we suppose understood the phenomena in little bit detailed manner, that suppose we have thrown one stone over here. Now this stone has impacted here and produce some crest initially. So in the wave we can say that it is just like crest like phenomena is observed. At the same time, it also experiences trophies also. So here we can say that if we go properly, then we found one important phenomena. That is what? See what I am going to do with a red color portion. So all the crest which are impacted by this stone in water are in the same phase, or we have to consider that they are in the same phase. Actually, this is the part where the maximum displacement of the particles are there. In a same manner, if you consider the green portion that I am going to draw, that is the maximum displacement in downward direction. That means they are also in the same phase. So they are trough. So all the particles lying on trough are in position of their maximum downward displacement, while all the particles that are lying on a crest are in the position of their maximum displacement. So this is actually individually are in the same phase, which these red colors particles and these green colors particles are individually, but they are in phase. That means all red type of arrangement or all particles which are experiencing these crest are in same phase. In the same manner, the particles which are experiencing this trough is also in the same phase. Now all these points are connected and form this type of circular arrangement or a plane. This plane is called wavefront. That means this locus of all such points oscillating in the same phase is called wavefront. So in short, we can say that the locus of all such point oscillating in same phase is called wavefront. So here in our case we can say this red color circle and a green color circle are the example of wavefront. So if I say this is a 1 and this green one as a 2, so they are representing wavefront. So in short, it can be defined that the continuous locus of all such particle of medium which are vibrating in same phase at any instant of time. So at any instant of time, if we consider, they are oscillating in a same phase or vibrating in a same phase. So in general, we can say that the continuous locus of all such particles. So here not only the locus, but we can say that in detail, if we want to define it, we have to say that continuous locus of all such points or all such particles. Of the medium. Which are vibrating in the same phase are called at any instant also. So in general we can define it by this statement, and we define the wavefront. So this is the basic explanation of wavefront. Thus, a wavefront is a surface of constant phase. So here we can say that what are the characteristics that a surface of wavefront is surface of constant phase the speed with which the wavefront moves outward from the source is called phase speed. So here obviously the locus that is developed or the particles wavefront that is developed is also moving out. You can consider that where the stone is thrown, then the first wave is emerged, then this wave moves further and a new wave that is also emerged from inside, then this is third, this is fourth. So until up to the impact remains there or impact is continuous, then the new wavefronts are emerging. So the wavefront which are moving outward from the source with a speed that is also called the phase speed. So the speed of them that is considered as a phase speed. So these are the basic concept behind wavefront. Dear friends, now we will understand that different types of wavefronts and how they are formed and how to understand the new Heightens Principle. First of all, we go through geometrical shape of different wavefronts, and we will show that geometrical shape wavefront depends on the sources disturbance. These are given by a simple different names. So if we go with the different types of wavefront, first that will be spherical wavefront. Spherical wavefront. So here I would like to show how the spherical wave be emerge. So in the case of wave traveling in all directions from a point source. So for a spherical wavefront we need point source. It is required a point source. So we can say that if it is moving from all the direction from point source, the wavefront are spherical in shape. So here we consider one point and we draw different rings, like this is black one, then I draw this blue one, then suppose I draw this green one. So all these are different waveforms and in the spherical shape that are located in all direction, but it is to be remembered that their source is a point. So if we consider that, suppose this is the line, suppose this is one line, or suppose this is another line, we say that these are different rays that we will calculate from it, and the wavefronts are, these are the wavefronts of different form, that is wavefronts. So this is the example of spherical wavefront. So we can say that when the source is point, like the wavefront are spherical in shape. This is because all such points which are equidistant from the point source will lie on a sphere, and therefore the disturbance starting from source S, here I could like to show that point S is a source. So the disturbance starting from the source S will reach all these points simultaneously. So here if I show point A, B and C, like, so this is suppose A, this is suppose B, this is suppose C. Now here I consider this is to be A dash, this is to be B dash, this is to be C dash. In a same manner, here it is considered as A double dash, here it is B double dash, and here it is C double dash. So all these points, that means A, B and C, we can say that light will reach, or the points, the effect of the source will reach at the same time. In the same manner, at A dash, B dash, C dash, the same phenomena happens, and the same happens at A double dash, B double dash and C double dash. So if they are having the same speed, if we arrange them and we connect them together, it will form a spherical shape. So for a spherical wavefront, we need point source, or we can say that if we have point source, then it can be a spherical wavefront. The example, another example that we can draw, and that is our routine bulb. Our routine example of bulb, that we can say that the light coming out from the bulb, that is in all the direction from the bulb, and therefore it forms a spherical wavefront. If we observe bulb light from far away distance, we found that there is a very light but a spherical aura is formed around it, and we found that this is in the same direction everywhere at the same distance with the same speed. So this is considered as wavefront or a spherical wavefront with a point source. So in that case, bulb can be considered as point source. Another thing, that is cylindrical wavefront. So the second form is, that is cylindrical wavefront. So what are the condition for the cylindrical wavefront? So we can say that cylindrical wavefront, So what is the condition for that? If we are given a cylindrical wavefront, then what is the source required for it? So we can say that when the source of light is linear in shape, so linear source, so we can say that if the given source is a linear in nature, then whatever the wavefront we observe is cylindrical. Suppose a fine regular slit. The wavefront is cylindrical in shape. This is because the locus of all such points which are at equidistance from the linear source will be cylindrical. We can show that with example. Suppose I have one source S as given this straight line or a linear source. Let's consider our tube light to be this type of linear source. if this linear source is given and then we draw an equidistance lines from it, like we consider here an equidistance light source is drawn, we can say it will form cylindrical shape in nature. Here it is very good to know that all the particles which are emerging from the point are in the direction here. We can say these are the point of same speed. Here we can consider these are the point with same speed. Here it is like this. So here we consider that if the source is linear, then it will form a cylindrical shape wavefront. So the wavefront will be of cylindrical shape, and all the points emerging from this linear source are lying at the same distance after same time. If we connect them together and form a locus of them and accumulate them, then we find that it will give us this cylindrical shape. So this cylindrical type of wavefront is the example of a linear source. So as I have said that the tube light in general is considered as a linear source if somewhere is tube light is kept on and we found the aura of light around it, we found that it is cylindrical in shape. In the same manner, now we move further and find the third type of wavefront. The third type of wavefront is a very simple wave, and that is called plane wavefront. Plane wavefront. So what are the necessary requirement for the plane wavefront? So it is interesting to know that as a spherical or cylindrical wavefront advances, its curvature decreases progressively, and so a small portion of such wavefront at a large distance from the source will be plane wavefront. So if we consider this point source or a linear source at a large distance from the source, so we can say that whether the source is linear or the source is a plane, but at a large distance it lost its curveness and becomes plane, and that is called plane wavefront, and they form this type of plane wavefront nature. So at a large distance, any source or any light that is emerging from any source that is lost its curveness and becomes flat, or we can say plane, and that is called the plane wave front. If we consider the point from them, we can simply say that they form this type of uniform manner of light emergence, and all these red particles are in the same phase. That shows the nature of ray, while when we connect them together they will form a plane. That plane is considered as wavefront. So locus of the particles in a same phase at any instant of time are wavefronts. So here it is interesting to say that wherever we have drawn this red line in the figures above, here, here, we have written the term that is ray. You can say that here this is ray, this is my wavefront. So what is actually this ray terms comes out from the information. So it is interesting to know that it is seen that whatever is the shape of the wavefront, the disturbance travels towards along straight lines emerging from the source. That is, the energy of a wave travels in a direction perpendicular to the wavefront, and an arrow drawn perpendicular to a wavefront in the direction of propagation of wave, that is called ray. So here in above figures, if we want to define the ray of light or what is ray, then we can say that an arrow drawn red colors arrows that we have drawn, an arrow drawn perpendicular to the wavefront but in which direction? So it is in the direction of wave propagation. In the direction of propagation of wave, in the direction of propagation of wave is called ray. So it is very clear that how to define a ray. We can say here that an arrow drawn perpendicular to the wavefront in the direction of propagation of wave is called ray. So this is the simple explanation of ray. Some more point that we can add up. A ray of light represents the path along which light travels. So it is very clear. So it represents the path along which light travels. Second thing, if we measure the separation between a pair of wavefronts along any ray, it is found to be constant. That is, this illustrates two general principles that rays are perpendicular to wavefront. So the nature that rays are perpendicular to wavefronts and second thing that we can say that the time taken for light to travel from one wavefront to another wavefront is same along any ray. So the time taken for light to travel from one wavefront to another, from one wavefront to another is the same along any ray. So these are the basic characteristics, and in case of plane wavefront, the rays are parallel. In case of plane wavefront, rays are parallel. In a second thing, that a group of parallel rays is called beam of light, which are called beam of light. In case of spherical wavefront, in a spherical wavefront, we can say the rays either converging to a point or diverging from point. So that can be converging to the point or diverging to a point. So these are the basic examples that we can say how they behave. So suppose for plane wavefront we draw this type of lines, then this is our plane wavefront, then we can say the rays are parallel because the nature of ray is to move perpendicular to the wavefront. And in the same way, if our source is point like if our source is a point source, then the wavefront either be converging or it can be a diverging like this. If we consider this is the point, then here we can draw a light like this. It can be considered like this. So these are suppose coming inward and each one is perpendicular to the plane for the given local point. So that is considered as a converging type of nature. So they are converging, as well as if point source is given in a such a way like wavefronts are coming out from that, it can also have the nature. So this red one is obviously a ray, and here I can draw a line like this, emerging out and perpendicular to a plane on a local level. So these are the converging and diverging nature of light ray when the source is point. So here we have to consider that this is point source, this is point source. So we can say that these are point source, point source, and these are spherical or a plane wavefront. So here and here the wavefront is given. So these are the information regarding wavefronts.